I'm going to be going back and forth between arguments on page 385 and 394, if you're interested. One group of them are all invalid, one group are all valid, but I need to get something more complicated here so we can encounter all of the little problems. We've seen a couple of them already, but there are a few more. All the little problems you might encounter with this procedure. So hopefully, we'll find some of them. We'll start with number 1 on page 385. Well, that looks simpler than the ones we finished off with before the break. We should be able to knock this out. I'll do the first few of these. We assume the premises to be true and the conclusion false. That would be a proof of invalidity. Only one place to proceed here, and that would be with the conclusion. Only one way for a wedge to be false. That's if both disjuncts are false. So we're going to transfer those truth values to any other occurrences of B and C. There's a B. There's a C. Can't do anything with that third premise. Maybe something has opened up in one of the first two premises. I think it has. In the first premise, we now know that A must be false. For if it were true, while the consequent B is false, that would make a false horseshoe. But we're trying to preserve its truth. Well, there's an occurrence of A right there. I now know something about D in the third premise. I know that D has to be true. Trying to preserve a true wedge, one side of which is known to be false. If that other side were false as well, that would be a false wedge. But we want to keep it true if we can. And if we transfer D's truth value to that other occurrence of D, stop and make sure that justifies a true horseshoe there in the second premise. And does it? Yes. It sure does. So there are no problems with that one. That is an invalid argument form. Right? Invalid argument form. Questions about that one? Another pretty simple looking one. Assume the argument form to be invalid. It means true premises and a false conclusion. Our conclusion is already justified, as it is simply C. There are two other occurrences of C. Transfer those truth values. And now I would say, I know the truth values of a couple symbols here, but the most obvious one would be in the second premise. A would have to be false in order to justify a true horseshoe whose consequent is already established as being false. There's an occurrence of A right there, so I'm going to transfer that truth value. Now let's see. Trying to make that wedge true. The left-hand disjunct, A, is known to be false. So to preserve that true wedge, that dot, in other words, the right-hand disjunct, that had better be what?
True.
But you know what? It can't be. Because one side of my dot is already known to be false. So I don't care what B is. That's a false dot any way you look at it. So, procedure cannot be completed. That's good. Means this argument form is valid. Questions about that one? So number 4 on 322 if you're interested. I think this one might have a little problem for us to figure out what to do about the problem. We'll see. Let's all make the initial assumption of invalidity. Well, not much to do in the first premise. In fact, nothing at this time. I know something about the second premise, and I know something about the conclusion. What can you tell me about either one of those? Yes?
On the second premise, if the curl is true, then the dot must be false.
That's right.
Just like in the conclusion, if the curl is false, the wedge must be true.
Okay, you know what I'm going to do? This does bring up something that we haven't done before. We have two simple statements that occur a few times in the argument. For all we could tell, we're not sure what either of them has to be, because there are many ways. There are 3 ways to justify a false dot, 3 ways to justify a true wedge. I am going to transfer the truth values of that dot and the wedge to the other dot and the wedge. Now you can only do this when it's a wedge of G and H that occurs somewhere else. Okay? I'm going to transfer the truth value of that dot to the dot of G and H up there. It's got to be the same dot, same conjunction. So I know that has to be the case. Now look at that top premise. See? That has to be the case. I already see that that horseshoe cannot be true. Right? All right, so you might want to make some notes or something in your notebook of what we did here. We had 2 simple statements, each one of which occurred 3 places in the argument. From what we established in that second premise and the conclusion, weren't sure of what G and H had to be. But the same conjunction of G and H occurred up there. If it has to be false, it has to be false there. And the same disjunction of G and H occurred here. If it has to be true in the conclusion, it has to be true up there. And just with that information alone, we can determine there's no way for that horseshoe to be true. So that saves a lot of time if you're confident you know what you're doing. Otherwise, you're going to have to try a whole bunch of combinations for G and H. A few combinations. But that shortcut's much better. Any questions about that one? No? I think I'll stay on that page. Might have a similar situation here. That's good. Got to remember how to resolve the little issues. Okay, so we'll make our initial assumption of invalidity. True premises, false conclusion. Once again, we know two symbols, truth values, but they happen to be connectives. So this is a similar situation to what we just encountered. Let's see if you could finish it off. I think you're going to run into something similar. Got it? Oh, maybe it's not the same thing. Did you have to transfer truth values? No, huh? I know that dot has to be true, right? I can stay right there and put in the truth values of t for both I and j. Transfer those. Let's see, that's going to be a true wedge. Now, if you had gone up here, you would have found the contradiction in that first premise, right? So again, you have to be real careful when you complete truth values, for every symbol in a premise or a conclusion, especially when you're transferring them. You have to stop and make sure that it all adds up to the original assumption. If you miss that, you'll think that you completed the procedure. You'll think that it's therefore invalid, when in fact it's not. This is a valid argument form. Let's look at a longer one here. I want to find an example where we can apply just a stroke. Let's say say we have that situation right there. We can go ahead and apply a stroke there, say it doesn't matter what D is, because that dot is false just by virtue of J's being false. So that's another technique that I don't think we've come to that yet, but let me remind you, you never transfer strokes to other occurrences of D. That means it doesn't matter what D is right here. It might matter what D is somewhere else in the argument. Gee, I wonder how long the long truth table of this would be. Very long, right? Because it doubles in rows every time you add a unique simple statement. 4, 8, 16, 32, 64, 128, 256, 512 rows long. So on your test, I'm going to ask you to do long truth tables for some of them to determine validity or invalidity. And in that case, to make sure you are doing the long truth table procedure, I'm going to ask you what some of your rows or columns look like in terms of T's and F's. Now, on those examples that I'm going to ask you to complete a short truth table proof, this is what we're doing here. I'm going to have so many letters in it that you're not going to slide by doing a long truth table proof of it. You understand the only thing I could ask you about this on a test, and this is going to be in a true-false format, is if it's valid or not. I can't ask you what your particular row looks like because there are several possible completions of this. So let's see if we can work this out. Not good places to start. Doesn't seem to give us much to go on. I hope something breaks here pretty quick. What do you think, R? R's got to be true. So we've justified our assumption that that conclusion is false. Well, good. We see a couple R's. This might be helpful. All right, now I know what that wedge is, but I want to take like the simplest assignment you can find. I think it should be that curl right there. That curl is known to be false. Okay, now we're going to have to take one of our shortcuts here and transfer truth values from connectives, or at least supply truth values of connectives. Yeah, is that a question or you have a suggestion?
Yeah, how did you know how the wedge, or what the wedge is?
Where?
The one that you said before, you were like, oh, I already know what the wedge is.
This one right here?
Yeah.
That wedge is true. I don't care what T is. Because one disjunct is already true. Right? I also know what this dot is right now.
Oh, okay.
That dot is false because one side of it is false. Doesn't matter what's on the other side. Those are the only two places I have to go to right now. So we have to turn to those connectives. We have no letters here whose truth value we know. So I'm going to stay right here and say, look, I know that's a true wedge, and I don't care what T is right there. I can't transfer that slash to N. Well, there are no other T's. So do you understand what we did here? By virtue of one disjunct being true, that automatically makes the wedge true, regardless of T's truth value. So now we have something going here. What?
True. Dot has to be true.
Good, that dot has to be true. Trying to preserve a true horseshoe. The antecedent is known to be true. If that consequent were false, that would be a false horseshoe. Right? Well, it does matter what M and U are. There are three. Oops, no, it doesn't. My mistake. We know what M and U are, don't we?
True.
We have an M. Well, we're good so far. Let's see. There is only one symbol here that I know, or whose truth value I know. It's in the second premise. Yes?
The first one, oh, sorry. The second one has to be false.
What? Second one what? What?
the second dot, or the only dot,
This dot right here?
yeah,
Why?
has to be false.
Yeah, why?
Because, if the first one is, the curl is false. Wait a minute.
Yeah, you're right. No.
No, I know, I did it a little while ago and I'm trying to remember where I was.
We mentioned it earlier. We said we could go to that dot. The left-hand conjunct of that dot is the curl. So the left-hand conjunct is known to be false. That's a false dot. And I don't care what S is right there. It doesn't matter. So let's notice something here. T could be true or false, and T occurs nowhere else. S could be true or false, and S occurs nowhere else. We don't have to worry about them any other place. That's the only place they exist. Okay, now I'm looking still at that second premise.
Well, then you know that, if the consequent is false and the horseshoe is true, then the wedge has to be false as well.
That is right. Does that tell you anything else in that second premise? It does.
The
What?
wedge is false, then Q and O are false.
Both O and Q must be false. It's the only time a wedge is false. Right? I think we're good to go here. Here's an O. I'm going to transfer that truth value there. And now, don't know anything about this. I know something in that first premise, though.
The second dot has to be false.
That dot is false. It doesn't matter what P is. Right? One conjunct, one false conjunct makes a false dot. Doesn't matter what P is. And now, still looking at the first premise. What can you tell me?
The horseshoe has to be false.
Horseshoe.
The dot.
The dot.
This dot,
And, yes,
trying to keep the horseshoe true. The consequent is known to be false.
sure.
So the antecedent must be false as well. The antecedent is the dot. Now, what does N have to be?
False.
N has to be false. We're trying to preserve this value right here, a false dot. One side, one conjunct of which is true. So the other conjunct had better be false to preserve that false dot. So that was a good example right there. We got the practice of knowing that we can, as a last resort, you always want to work with the letters, truth values. But as a last resort, you can't transfer truth, well, actually it was the last example. You can transfer truth values of connectives so long as they have the same components. In this case, we were using this slash effectively. You have to be confident in your definitions in order to apply that slash. Slash doesn't mean I don't know what it is. Slash means we don't know what it is and it doesn't matter what truth value is. Right? I think we might be ready for a volunteer. do this one. Well, I notice we have a situation here where we have the same conjunction occurring twice, and we have the same disjunction occurring twice. Anybody want to try your hand at this? I think it's going to go down real quick. Any volunteers? That's going to go right down. Right? So you know everything in the conclusion. And everything in the conclusion occurs elsewhere.
But the T on the top is true, is it?
We don't know that at this point. No. Because there are three ways a horseshoe may be true. False, false is a true horseshoe. What?
In the conclusion, the antecedent has to be true, and the consequent must be false to give a false horseshoe.
True. But now we know everything else in the conclusion, don't we? Because a dot or a conjunction is only true if both conjuncts are true. Now wait a minute. I think I should transfer those truth values. You could do that and find a contradiction. Right? Let's say I transfer those truth values, find the contradiction right here. It's not a false wedge. Right?
Right.
Okay, let's say you didn't take that route. Let's say maybe we'll learn a lesson here. Maybe you said, well, I'm going to make R false and S false because that's what the false, that'll keep a false wedge. And then you would look at these and say, yeah, sure, that's a false horseshoe. Because we would have failed to transfer those. So that illustrates the need to transfer those truth values. Because when we do, we see immediately that that's a contradiction. So let that be a lesson to you. I have no idea how this is going to work out. It'll be fun to read, though. Oops. This is number 8 on 394 if you're interested. Maybe we should stop and read some of this. How about that second premise? Yes?
If you, then not either G or not G.
There you go. but that first premise.
Want me to continue?
You gonna let him hog all the reading? Go.
If B,
Oh,
Then-
sorry, that's my fault.
then,
Let's go again.
if B, then, if either O or not O, then either T or U.
Boom. That's it. Not at all sure if this is going to be a problem. I guess we'll see. Where do you want to start? Only one place to start.
Conclusion.
Yep, the conclusion. What do we know?
Antecedent is true, consequence false.
Now what?
Okay, the truth values and the false values to the corresponding letters.
Let's see, I know the truth values of
The consequence.
one. I know the truth values of two symbols here. And there are only two. Give me one of them.
The consequence in the first premise. has to
Which
be
is
true.
what?
Which is the horseshoe.
Yes,
Has to be true.
right. And do we all understand why?
Yeah.
What else do I know in that first premise at this time?
That if the wedge is true, I mean the horseshoe is true, then it must be true, everything.
No, I think there's something right here.
The wedge false.
That wedge is, that's false right there. Right?
Correct.
Any question about that? You know what? I'm going to go ahead and make that wedge false and put a stroke on U. I notice that U doesn't occur anywhere else in this argument.
It occurs on the second premise.
Oh, does it?
Yeah,
Okay,
second.
then. Well, you know what? Let's see what happens. Let's see if it does matter here. Let's go ahead and do this. All that means is U's truth value doesn't matter there. So it might matter here, but no matter what we make it, true or false, you never have to go back and check that. Agreed? Okay, now someone told us something about this right here.
It's true.
That's got to be true. Still in the first premise. I think that has opened up something else for us. Yes?
Sorry, the wedge in the first premise,
This one?
why, no, the second wedge, the one that we know is false, why do we know that's false again?
Because one side of it is false. Oh! Thank
Because
you.
that could be true or false.
Thank you. My apologies. That's bad. Water under the bridge. Forget about it. I've already forgotten about it. Done. Okay, well, let's see. Do we know anything then at this point? Anything? Maybe not, huh? think we're gonna have to have a new solution to this because this hasn't occurred before. Can anybody think of a sort of a path of least resistance? We have 2 O's. We have 2 G's. We only have 1 U.
2 years.
Oh, we have 2 U's.
Well, I think I see something.
Go. There's nothing we know for certain, but there's still a better approach than
You know how
others.
she said that the wedge on the first premise, on the consequent of the second horseshoe?
This
You
one
know
right
how she
here?
said that it could be either true or false, right? Yeah, that one.
Yeah,
She
as
said
things
it could be
stand
true
right
or
now,
false.
yeah.
Well, it does